This lesson, number 3-3, is writing and graphing linear inequalities. And so instead of equations like we have been doing, we're going to be doing inequalities. So first, to review a couple of things that you already know how to do graphing. So first of all, if you've got colored pencils, that's going to be helpful for today's lesson. If you do not have colored pencils or highlighters or anything with different colors, you're going to have to just use your pencil to shade differently. Okay, so you're first going to graph the equation and follow the directions. So the first thing you were supposed to do is graph the equation y equals 3/2 x minus 8. So y-intercept at -8, then you're going to go up 3 and over 2, and so there's my line. The next thing you're going to do, it says shade above the line. And so if you think about this line as being like the roof of a house, and you're standing there, you're below the roof, the sunshine is above the roof, and so if you're going to shade above the roof, then you are going to shade like that. Then the next one, it says with a different color, you're going to shade below the line. So below the roof or below the line, that's where you were, and so you're going to shade like that. So that's all you have to do for that one. Okay, next one, similar, you're going to graph the line, and so that's what you should have graphed. Negative slope, -3/4, and then you're going to have a y-intercept at 5. And then it says shade above the line. So this time, if that's the roof of a house, where are you going to stand if the sunshine is above the roof? So the sun is going to be shining above, and here's your house, and you're going to be standing below the roof. So that's what you need to be thinking of as you're doing this. I had a teacher that just told me, just think about it as the rain's coming down, and where's the rain coming? That's above the roof. So above is going to be there. And then with a different color, or again, if you don't have a different color, then use your pencil to shade differently. You're going to shade below the roof, below the line. Okay, the next thing we're going to do is we are going to circle the ordered pair or pairs, so it might be one, it might be both, it might be neither, that are solutions to the inequality. So just like when we did an equation, we plugged in to see if it was true or not. So that's what we were doing. And so we're going to do the same thing, except for this time, instead of an equation, we have an inequality. And so the inequality that we're going to do for number 1 is going to be the inequality x is less than 2. So what you're going to do is you're going to take the first ordered pair, this is x and this is y, and you're going to plug in appropriately. So this is x, it's going to go in place for x. There's nowhere to put the 2, and so you just have to say, is that a true statement? Is 3 less than 2? The answer to that is no. So you're not going to circle that first ordered pair. Okay, the next one, I'm going to take this x and this y. And so I'm going to plug this x in for the x, -1, and then there's nowhere to put the 4. So is that I've got in green, is that a true statement? Is -1 less than 2? That one is true. So what I'm going to do is I'm going to circle that ordered pair because that's a solution to the inequality. Okay, next, number 2, the inequality y is less than or equal to 7. So we're going to do the same thing. So we're going to take our x and our y, and we're going to plug in appropriately. So since this says y, I'm going to plug in my y. So I'm going to say 8 less than or equal to 7. Is that true? That's not true. So I'm not going to circle it. So I'm going to leave that alone. And then the next one I'm going to do is I'm going to take the second ordered pair, and I'm going to plug in for y is 1 less than or equal to 7. That one is true, and so I'm going to circle that ordered pair. Okay, number 3, y minus x is less than or equal to 6. So again, one at a time, I'm going to take the first ordered pair, and I'm going to plug in appropriately. So instead of y, I'm going to put -2 minus, and instead of x, I'm going to put 3. And then I have to see if that's true or not. What's -2 minus 3? It's -5. Is that less than or equal to 6? Yes. And so I'm going to circle that ordered pair. Now I need to try the other one. Is 4, 1 going to be a solution? So again, I'm going to plug in 4 for x and 1 for y. So 1 minus 4, and that's -3. Is -3 less than or equal to 6? Yes, that one is also true. So actually both of these are solutions to the inequality. So an inequality can have a lot of different solutions. In fact, most inequalities have an infinite number of solutions because there's so many things that could be less than 2 or greater than 5. And so you can have more than one solution very easily with an inequality. Okay, and then last, number 4, the inequality is 4y minus 2x is greater than -3. So let's go ahead and take the x and the y and plug that in. So I want you to pause the video and try to plug in and see if that's true for both ordered pairs. Okay, what you should have done is you should have said 4 times the x, 4 times the y. So you said 4 times 4, and then minus 2 times the x. And so that's going to be 16, and negative 2 times negative 1 is positive 2, and so that's 18. Is that greater than negative 3? That is greater than negative 3, so I'm going to circle that first ordered pair. Then I have to try the second one, so this x and that y. So I'm going to say 4 times y minus 2 times x. So that's 12 minus 2 times 6 is 12. 12 minus 12 is 0. Is 0 greater than negative 3? That one is also true. So I'm also going to circle that ordered pair. Okay, so before we actually start graphing linear inequalities, there are some things that we need to know. So to graph an inequality in slope-intercept form, so it's y equals mx plus b form, you might see one of these 4 situations. So you might have y is greater than mx plus b, y is less than mx plus b, y is greater than or equal to, or less than or equal to. So there are certain ways that we graph these lines. So instead of, when you do an equation, you always just graph like that. But with an inequality, there's different ways to represent things. So if you have a greater than or a less than, you'll notice that you're going to be using a dashed line. So you would do a dashed line like that. Okay? Now if you have greater than or equal to or less than or equal to, then that means that you're going to do a solid line. So like that. And that's kind of, if you remember when you did inequalities on a number line, if you did like x is greater than 2, you would do an open dot. And if it said greater than or equal to 2, you would do a closed-in dot. That's kind of the same idea. So if you have an equal sign, you're going to fill in that line and make it solid. Okay, now the other part about it is if you have greater than or equal to, you're going to shade above the line. So you would shade above your line. So wherever the sunshine is, like what we did in the warm-up. If you have y is less than or equal to, you're going to shade below the line. So like that. And so there's a lot of things that you have to watch for with linear inequalities that you don't have to watch for when you're doing equations. So you're going to have to pay attention. So every time you graph a line for your inequality, you're going to have to ask yourself, should it be a dashed line? And do I shade above it or do I shade below it? So we'll talk about how to do that. Now, the other thing we want to talk about is vertical inequality. So what if you have a vertical line? Okay, so you still can do the dashed line or the solid line. But then the whole sunshine and the roof thing becomes really hard because, if you have a vertical line, the sun could be shining on both sides, right? So what we have to think about is if we're on an XY axis, and if we have a vertical line like this, where's the greater than? So if you have greater than, where are the numbers? So if this is 4, where's the numbers bigger? They're over here. So that's why if it says greater than or equal to, you're going to shade right. If you're looking for less than, then you're going to be shading over here because that's less than whatever number this is. So you would shade left. Okay, so we're going to practice doing this. So with this written up there, so you keep referring back to that, we're going to go to number 5. We're going to graph the solutions to the following inequality. So when we graph a line, all of the points on the line are solutions. So when we graph an inequality, it's going to show all of the solutions. So here's how you do it. You just graph the line. So y equals mx plus b. So you're going to graph starting at 3. The slope is 1. So you're going to graph this line. But then you have to stop and say, oh, wait, that's a greater than, not greater than or equal to. So I need to do a dashed line, not a solid line. So that's one thing that you can get marked off for if you do a solid line when you should be doing a dashed line. So that's something that is kind of a common mistake because people forget to look. So it's a dashed line. Now the other thing, since it says greater than, this is what we're looking at right there, we're going to shade above the line. So I'm going to take my pencil or colored pencil or highlighter or whatever, and I'm going to shade above that line. What that does is it tells us that all of these points are in the yellow right here. So all of these points, they're all solutions. They would all work and be true in that inequality. So that's what that's telling me. And so you're not going to write any ordered pairs because you couldn't write all of them. You're just going to show that picture. And so that's it. That's your answer. Okay, let's go to number 6. Graph the solutions to this inequality. So y is greater than or equal to. So greater than or equal to, I'm going to look over here at this one. So I'm going to be using a solid line, and I'm going to be shading above the line. So I'm going to start at 1. My slope is negative 1/3, so I'm going to go down 1 and over 3. Or I can go up 1 and backwards 3. I'm going to do a solid line. Still, you put arrows on. And then I'm going to shade above. So where is above that line? So again, think about the roof and the sunshine or the rain or whatever. And you're going to be shading above this line. Now you don't have to stay within the XY axis because it's really everything. It's everything beyond that. So, you can go outside the lines. It's okay. All right, so that's your solution. Again, you don't have to write any ordered pairs or anything. That picture, that graph, that is your solution.